All right, in Chapter 8, Section 2, we're not dealing with means, we're dealing with proportions. And so once you have a proportion and it follows a couple of characteristics, then we can use the normal to actually find these probabilities. So the sampling distribution of P, if it satisfies that the sample size is less than 5% of the total population, then N times P times Q is less than 10, we can go ahead and say that it follows a normal distribution, or it's approximately normal, as they're saying. So if we look at, if we have a population of 10,000 and we multiply it by 5%, that's 500. We have a sample size of 50. That's less than 5% of the population. So that's the first condition met. And the idea with that 5% is so that we don't use the same person over again. So we want to have a small enough population that, or a sample that we're not going to reuse a person with these proportions. And then the other one is the N times P times Q, which is 1 minus P, see if it's less than 10. So if we have 50, we multiply that times 0.4, and then 1 minus 0.4 is 0.6, we get 12, so we get something that's greater than. So we need to be, N times P times 1 minus P has to be greater than or equal to 10. I think I have this in the book, greater than or equal to 10. So these are the things that we're looking at for this section 2. So that's why we'll say it is a approximately normal because. And that means now we can find the probabilities, everything else, because of those two conditions being met. Here's how we find the mean. The mean is equal to our sampling distribution, or our sample proportion. So over here, the mean of our p hat is just 0.4. Kind of similar how the mean of our population, the mean of our sample would be the same. The standard deviation is going to be different. We have this formula right here, the square root of p times q over n. Again, q is just 1 minus p. So the square root of p times 1 minus p over n. So if we go to calculate that, we're going to be taking the square root of p times 1 minus p, all of that divided by our sample size, which is 50. So this is our standard deviation of our p hat. So this 0.069 seems really small, but again, that's about 7%, because we're looking at a proportion of 40%. So we'll go to 6 decimal places, so lots of decimal places, 0.069282. Again, that's just using this formula over here. So now we have all the tools that we need. What's the probability of obtaining x equals 23 or more individuals with the characteristic? That is, what is the p hat being greater than or equal to the 0.46? Well, again, they got the 0.46 because to find p hat, it's just the number of successes, like 23, divided by our sample size. So it's the number of successes divided by your sample size. That's where they got the 0.46. So to do that, we're just going to go to StatCrunch and find out this value. We're still going to be on our normal calculator. So our mean was 0.4. Remember, this was greater than 0.46. And now let's go plug in that standard deviation, which was, let's get it over, 0.069282. So that means 19% of the time we'll get 23 or more. Again, 23 out of the 50 is that 0.46. So we get 0.1932. Let's see what else they have for us. So 16 or fewer, again, that's where they're getting the 0.32. 16 divided by 50 is 0.32. And do the exact same thing, except that it's less than the 0.32. Just maybe looking at one more, getting it started. Number 9. All right, so again, we have this probability is 0.31. This is our P. We do a sample of 200 adults, and again, this is from a country, so we are assuming that 200 is less than 5% of the population. I guess it depends on what country, but still, 200 is pretty small for a country. Describe the sampling distribution of P of adults who do not have credit cards. So again, I'm going out on a limb and we're going to say it's approximately normal because those conditions are satisfied. And so they were, and then the mean is always going to be, what we think it is 0.31. And then the standard deviation of our p hat is going to be the square root of pq over n. So p is 0.31, q is 1 minus p, so 0.69, and divided by our sample size, which in this case was 200. So to 3 decimal places is 0.033. And so now as less than 27% have no credit cards. What is the probability then less than 20%? So this is my p hat. So I know what my mean is. My mean is 0.31. I type that into my normal calculator. There's my standard deviation of p hat. And I'm going to put less than 0.27. So it's doing very things similar that we were doing with the other means and standard deviations, but now we're doing with proportions.